Hey everyone, so when you're programming, you are constantly juggling collections of data. But here's the thing, not all collections are built the same. Today, we're going to break down 3 of the most fundamental data types you'll ever use: lists, tuples, and sets. And trust me, knowing the difference isn't just for, passing a test. It's absolutely essential for writing clean, efficient, and bug-free code.
Okay, let's just dive right in with a little experiment. We're going to start with the same 4 letters, A, B, C, and then another A. How you actually type them out. First up, the list. The source shows us it's made with these super common square brackets. And just take a look at the contents. We've got A, B, C, and then another A. Pretty standard stuff. This is probably the one you see all the time.
Next, we have the tuple. Now, the big difference you see right away is the syntax. It uses parentheses. But here's what's really interesting. The stuff inside, ABCA, is exactly the same as the list we just saw. So hang on to that thought.
And our third container is the set, which uses these curly braces. Simple enough. But hang on a second. Look really closely at what's inside. We have A, B, C, but where did that second A go? Okay, now things are getting interesting.
And that little mystery of the missing A brings us right to our first major point of comparison. It all comes down to 2 really simple concepts: how these guys handle duplicates, and whether or not they even care about order.
So, what happened to that second A? Well, it's because sets, by their very design, only care about unique items. Think of a set like a bouncer at an exclusive club. It only lets each unique guest in once. If you try to add something that's already inside, the set just says, nope, already got one, and moves on. This makes them an incredibly powerful tool for things like, say, getting a list of unique visitors from a massive log file. It's instant and automatic.
The other big piece of the puzzle here is order. With lists and tuples, the position of every single item matters. The first thing you add is at position 0, the second is at 1, and so on. They remember the sequence you put them in. Sets, on the other hand, they are totally unordered. It's more like a grab bag of items. You know what's in the bag for sure, but there's no such thing as first or last. And that's exactly why you can't ask a set, hey, what's the item at position 2? Because position is totally meaningless to it. Now, this difference in how they handle order directly changes how we get our data back out. For a list or a tuple, it's easy. You can just grab an element by its index, like mylist0, because their order is reliable. But if you try that with a set, well, you can't. There's no such thing as an index. You can check if an item exists in a set, and by the way, this is incredibly fast, but you can never, ever ask for it by its position. Okay, so we've kind of sorted out sets, right? They're the unique, unordered specialists. But what about lists and tuples? I mean, they still seem almost identical. They both keep order, they both allow duplicates, so what's the deal? Well, the key difference between them boils down to one very powerful concept.
And that concept is called mutability. It sounds a little technical, I know, but it's actually a super simple idea. All it means is, can this thing be changed after you've created it? This one idea is the bright, shining line that separates a list from a tuple.
And here it is, the core difference. Lists are mutable. That means they're flexible, they're dynamic, you can add new things, get rid of old ones, or change an item that's already in there. Think of it as an editable shopping list. Tuples, on the other hand, are immutable. Once you create one, it is set in stone. It's locked. You cannot add, you cannot remove, you cannot change a single thing. It is permanent.
It's really easy to look at that and think, well, that sounds like a weakness. But here's the secret. That limitation is actually a tuple's most important feature. It's a superpower. By making that data unchangeable, you're protecting it from being accidentally messed up somewhere else in your program. This makes tuples absolutely perfect for storing things that must not change, like, say, the days of the week or a person's date of birth.
And just to complete the picture, what about sets? Where do they fit in? Well, sets are mutable. You can absolutely add and remove items from them. But, and this is a big but, because they don't have an index, you can't just update an item that's already in there. To change something, you'd have to remove the old item first and then add the new one.
All right, so we've looked at duplicates, we've looked at order, and we've looked at mutability. Let's bring it all together now. This is where the rubber meets the road, and we figure out exactly which tool to grab from the toolbox for any given job.
Okay, this table right here is our ultimate cheat sheet, so let's run through it.
First up, the list. It says yes to everything: order, duplicates, and being changed. It's your flexible, all-purpose Swiss Army knife. It's the default for a reason. Then you've got the tuple. It keeps order and it allows duplicates, but it gives a hard no to any changes. This is your go-to when data safety is the #1 priority. And finally, the set. This is our specialist. It's all about one thing: uniqueness. It doesn't care about order at all, and its main job is to give you lightning-fast checks to see if something is in the collection. See, it's never about which one is best. It's always about which one is the right tool for the job you have right now.
So the next time you're writing some code and you need a collection, don't just automatically reach for a list. Stop and ask yourself, does the order matter here? Do I need to allow duplicates? And maybe the most important question of all, should this data ever be allowed to change? Which brings us to this really cool final idea in programming. When is a limitation actually a feature? Because as we saw with tuples, sometimes the strongest and safest design is the one that intentionally protects you from making your own mistakes.